Here I'm going to discuss some of the very important functions of the liver, and also feel the need to mention the gallbladder, as you see located here, because it is in such close proximity to the liver. So starting with the liver in general. Liver is the largest internal organ of the body. It's about 3.3 pounds. It's divided into lobes. Its the main exocrine secretion is bile, and it aids in the digestion of fats in the duodenum. Now, it chemically modifies substances and absorbed in the GI tract, and it converts poisons into less toxic forms. So it's a very important function of the liver, and this is why it's so large. It's kind of like the main filter. It's a detoxifying of some of the toxins that the body takes in. It's also one of the only tissues that can regenerate itself, indicating its importance. This tries to show a little bit of its orientation in the body, and it produces most of the proteins found in the plasma of the blood. So it's located right there, kind of tucked up under your rib cage. If you feel under your rib cage, you can actually feel your liver. Now, some very important functions of the liver. There's three main ones. All blood leaving the absorptive surfaces of the digestive tract. So we have entering the hepatic portal system, flows into the liver. Then we have the liver cells extract nutrients or toxins from the blood. And this is before they reach the systemic circulatory system through the hepatic veins you see here. So this is kind of like intermediate filter going through. Lastly, the liver removes and stores excess nutrients, corrects nutrient deficiencies by mobilizing stored reserves, performing synthetic activities. So it's kind of not only filtering things, it's sensing and regulating and changing so that our body can do its best it can to maintain homeostasis. Continuing on, to give you a little bit of that complexity of the liver, it regulates the composition of circulating blood, waste product removal, nutrient balance, and nutrients can be carbohydrates, lipids, and amino acids, vitamin storage, A, D, E, and K vitamins, nutrient storage for iron, drug inactivation, and these are some of the crazy pathways that go on. Arrows indicate that it occurs, and these lines here means that it could block that. Also have some unknowns here indicating some of the pathways here. Now, do I need to know all the kind of complexities here of the stimulatory and inhibitory effects? No. I want you to understand some of the many functions that the liver performs. In particular, here's just 6 very important regulations that it does. The hepatocytes here, the liver cells, how they function. Well, they produce bile. See a bile duct right here. It's processing of bloodborne nutrients and a storage of fat-soluble vitamins. They're also important for that detoxification step. And as you see here, a very good amount of surface area allowing this to occur. Continuing on, what does the liver do? I love that question because there's about 500 vital functions of the liver. Very hard to kind of summarize them, kind of only a couple. But I try to put like 8 kind of major ones here. Phagocytosis and antigen presentation. It removes damaged or old red blood cells. It synthesizes plasma proteins such as albumin, reabsorbs hormone, removes antibodies and converts to amino acids, traps some lipid-soluble toxins, removes and stores certain toxins. So it's keeping the body clean, and it also synthesizes and secretes bile. Now, when I'm referring to toxins, this isn't like, oh, you drink something toxic. There's a lot of potential harmful things that could occur in the body, especially in high amounts. It's helping clean some of that up. A lot of drugs that may be taken, prescription drugs, usually go through and are processed in the liver. This is why a lot of times doctors will check for liver. They watch those blood liver levels and how that's kind of operating, because that can be an indication of some of the stresses that might be put on it, or some of the particular products it might be putting into the blood system as a reaction to something. This bile I've been mentioning, the functions of bile, it's dietary lipids are not water soluble. The chemical processing in the stomach creates large droplets containing lipids. So the removal of bilirubin also results from the breakdown of red blood cells and breaks down cholesterol. Pancreatic lipase is not lipid soluble, interacts only with the surface droplet of the lipid. So what we want to do is kind of like, we call this emulsify, or break that apart, increasing that surface area, allowing the body to better absorb or break down these particular products. Lastly, bile salts break apart or emulsify, as I said. They increase the surface area to allow enzymes to work a little bit better. These tiny droplets are coated with bile salts, and that's what helps allow those enzymes to be able to perform their function. Lastly, I mentioned the gallbladder, and that's just kind of looks green in these images here. It's located kind of right behind the liver there. It's pear-shaped. It's a muscular sac. It stores and concentrates bile prior to excretion into the duodenum of the small intestine via this bile duct. So you can see here's our pancreas again, here's our gallbladder, and here's our bile duct entering the duodenum, which is the first beginning part of the small intestine, and dealing with the chyme as it immediately enters, or exits, I should say, the stomach. The cyst duct extends from the gallbladder, and this is allowing this bile to be immediately released into the beginning part of the small intestine.